So today we're going to start learning about how to program Arduinos. And so this is the beginning of a computer science or robotics unit where if we were to talk about the basics of any kind of computer science, programming or robotics, the idea is that you have inputs, things that come in and information that goes in. There is a some kind of controller that is going to make some decisions based on that input, and then a decision will be made by that controller to produce some type of output. Some example of this would be a design sent to a laser cutter where the computer determines how to move the machine and then sends directions to the machine to make those movements. When we talk about computers and programming microcontrollers for robotics, these inputs can be called sensors. A sensor is something that will take information from the environment, such as sensing temperature, light, sound. The process will be controlled by a computer, something that can be programmed, and the output will be given by something called an actuator, something that can act and do something. So the sensor will read from the environment or the physical world and give that information to the controller. The controller will then process that information and determine an outcome, an action that will be made, and send a directive or a direction or a command to the actuator, which also will likely interact with that physical system or the environment. Just as it's shown here, the actuator is going to interact with its environment, but it may just be something like displaying a value. Um, so there are all sorts of different types of sensors out there that can sense anything you could possibly want to quantify. And so touch and infrared light, certain chemicals like propane gas or alcohol, they can sense colors. They can sense distance from other objects, water flow, pH, soil moisture, motion, magnetism, position in space, all sorts of things. And so, if you want to program any kind of action, the first one of the things you want to ask is what information do I need from the environment to find an appropriate sensor to read that information. Actuators for robotics are usually like actual motors that are going to produce motion. And then other output devices may be displays or printers, speakers, monitors for computers. For our Arduino, an LED can be our output, and we can use it to flash lights, or this is a 7 segment display, are all things that can be used to do something with the information that the microcontroller is processing. These are the components that are in our specific microcontroller kit. I have green marked the ones that can be used as output, such as LED bar graph, the LED matrix, the buzzers, the motors, the LCD display, the infrared detection module. Those are all great actuators or outputs. And then the sensors, or the things that take information from the environment, have yellow dots next to them, like the potentiometer, push buttons, a keypad, sensor for sensing vibrations. There's a joystick, an infrared receiver, a photoresistor for detecting light. And then I didn't know about this one at the time, but this, I believe, is a humidity and temperature sensor, as shown in this circuit right here, where the humidity and temperature sensor is sensing the environment, specifically the moisture level and the temperature of the environment. The microcontroller is programmed to maybe read that setting every 10 seconds and then display it on this output, which is a liquid crystal display. So the interesting thing about these circuits is that if you build one, you can get them to do all kinds of different things by programming the processor differently. The processor is can be programmed to permanently, well, the code can still be changed, but programmed to have different code to do different things without having to change the circuitry at all. And this is very similar to the way our central nervous system works in our body. And in fact, computer science is often, we often use the body's central nervous system as a analogy to a computer. So the processing will depend on code. We can code this Arduino to do all kinds of different things with a push button and an LCD display, or with a temperature sensor and a speaker by changing the programming on the microcontroller. Here's an example of two very similar circuits that are doing different things based on different programming. And with our kits, we can do all kinds of fun things. This is a servo motor. It's also a link to a bunch of projects that involve the servo motor. And this is a link to a project that shows you how to code, make a circuit and code to drive this 8x8 LED matrix. So the microcontroller, which is what we're working with, is a tiny computer. They have inputs and outputs, and they can be programmed. And Arduino is a type of microcontroller. But these little tiny chips that you'll see on all sorts of electronics these days, on pretty much everything these days, are little tiny microcontrollers. And a computer has a bunch of them in there. And they are tiny computers. They have all of these things inside of those little tiny pieces. And Arduino is one of them. It has a microcontroller right here on it, along with some other things that make it easy to use for hobby programming, like built-in ports and a nice USB cable to talk to your computer, transfer information in and out. So the Arduino has digital input output pins that if your code says that you have an input or an output on pin 5, this would be where you would place it. And the ground there goes along with, if you're using these pins, you would use that ground right yonder, right there. There are also analog pins, and when you're using these, you would usually go into one of these two grounds. And the analog out pins are over here with the little squiggly line. Mostly we'll just be looking at code and placing the things where the code tells us to. There is an onboard LED on the Arduino that we will start off. You can always do things with this LED if you have no components to place on the Arduino. There's always that one LED on there. This LED here is the on key, and it shows you that it's on. It should be lit if there's power on there. And while the Arduino is uploading code, it flashes, and that's how you know that code is being sent through the USB cable, which is right there. And that's how we're going to power our Arduino and connect it to the computer for programming. There's a reset button. If you were to upload some code, like a song that plays once, you can push this button and get it to play again. You don't have to upload the code again. So the code in Arduino is called a sketch. A complete code that would allow the Arduino to do some function is called a sketch. And we're just going to be copying them from the existing sketches that are available online. And then in order to get full credit for your code, you will need to modify it, which will require you look at it a little bit and understand a very small part of the code enough to just change some values and make it a little different. Arduino code consists of two parts: the setup, where you define every little part in your in your system. You define all of the inputs and all of the outputs in your setup. And then it has the loop part where the actual main part of your code goes, where you tell the computer, the processor, to do certain things with the things you defined in the setup. So for example, here is the most basic blink code. It starts off with a little bit of background information. Everything in gray is ignored by the microprocessor and is there for the reader to be able to read and get a little bit of background information on what the code is doing. And so this first part gives us a little bit of background information. It says we're going to blink an LED. The setup tells us that there's an LED on pin 13, and we're naming it the output LED. And so then after this, we don't have to write output, we can write LED. So then in the loop, it says, hey, make that LED on high and delay for a second. This is 1,000 milliseconds. And then put that LED on low and delay for 1,000 seconds. So what this will milliseconds. So what this will do is it'll have it on for a second, off for a second, blinking on and off. And so you may want to check out some of these links right here, which are also available in the online editor, but you kind of have to search for them under libraries if you're interested in making the liquid crystal display work, which is a very popular option, although it does have a lot of wires. And so if you're not into a lot of wires and breadboard work, then it's not something you're going to want to do. It'll be optional, as is the Servo Library, which is also very interesting for students to get the servo to work, either by controlling it with a potentiometer, so that when you turn the knob on the potentiometer, it turns the servo motor, or the sweep, which does a regular movement of the servo motor that you could then modify really nicely. Right here is the sweep. It says down here to take that servo motor and go from position 0 to position 180, changing it 1 degree at a time and delaying 15 milliseconds between each and every degree. And then here it says now go back the other direction from 80 back to 0 by changing it 1 degree each time with a delay of 15 milliseconds. So what this is going to do is sweep the arm of that servo motor 180 degrees in this direction, and then 180 degrees back in that direction. You can change it to just do 90 degrees, and then it would just go, and then, but you better change this to go 90 degrees back, so it can go, uh. And if you mess with this, it'll change the timing. Increasing it will make it slower. Decreasing it will make it faster. You can also change the increments. You can have it go 5 degrees each time, and then it will not sweep as smoothly. So in the classroom, there are also a few books and documents with extra projects in there. If you are interested in going far with Arduinos, there is nothing to stop you. Please ask if you have specific questions, but we're probably going to diverge off into individual projects really soon.